2010 after my story, after it broke the New England Journal of Medicine, and then started becoming an important story. I decided I did not really want to be the Berlin patient anymore. I wanted to have people know me by my name, and so I decided that I couldn't be the only person in the world cured of HIV. It was at that point. I didn't want that anymore. I wanted more people to be cured. I wanted everyone with HIV to be cured, and so in order to do that, I had to release my name and my image to the public, and since then I've become kind of a cheerleader for HIV Cure.
Could you cure a disease that's supposed to be incurable? What if the key wasn't in some futuristic lab, but hiding in our own DNA, a secret that's literally ancient history?
All right, so for decades, HIV was seen as a one-way street, a life sentence. But then, one man's story just flipped the script entirely.
2010, after my story, after it broke the New England Journal of Medicine, and then started becoming an important story, I decided I did not really want to be the Berlin patient anymore. I wanted to have people know me by my name, and so I decided that I couldn't be the only person in the world cured of HIV. It was at that point. I didn't want that anymore. I wanted more people to be cured. I wanted everyone with HIV to be cured, and so in order to do that, I had to release my name and my image to the public, and since then I've become kind of a cheerleader for HIV Cure.
It kicked off this incredible medical detective story that stretches all the way from a modern hospital in Berlin, believe it or not, back to the time of the Vikings.
Let me introduce you to Timothy Ray Brown. For a long time, though, the world only knew him by his code name, the Berlin Patient. And his story? Wow. It's not just about beating the odds. It's about this crazy, almost unbelievable chain of events that made him the very first person in history to be cured of HIV.
So get this, it's this wild story of how one disaster actually solves another. Back in '95, Timothy gets his HIV diagnosis. Fast forward about 10 years, and boom, he gets hit with a really aggressive leukemia. To save him from the cancer, his doctors go for the super high-risk option, a stem cell transplant. They do one, then another, and what happens next is just mind-blowing. The leukemia, gone. And the HIV, that was gone too.
Now, this was no fluke. It wasn't just some lucky side effect from the chemo. See, his doctor, a guy named Gero Hutter, had this absolutely brilliant, almost insane idea. He thought, what if I find a stem cell donor who's not just a match, but who's also naturally immune to HIV? They didn't just treat him, they literally transplanted the cure into his body.
Okay, hold on. How is that even possible? How can anyone just be born immune to HIV? Well, the answer is hiding in our DNA. It's this tiny genetic quirk that basically works like a biological superpower.
So picture your immune cells, your T cells. On the outside of them, you've got these little proteins called CCR5 receptors. The easiest way to think about them is like door handles. For most strains of HIV to break into a cell and infect it, it has to grab onto that exact door handle.
So here you can see exactly how it works. On the left, there's the virus. It latches right onto that CCR5 door handle, and bam, it's inside. Easy. But now look at the right. See what happens when that door handle is just gone? The virus is totally locked out. It can't get in, it can't make copies of itself, the infection is stopped dead in its tracks. And this genetic superpower? It has a name, CCR5 Delta 32. It's a very specific mutation. Basically, a little piece of the gene that codes for that door handle is just missing. And because of that, the protein it makes is broken. It's non-functional, and it never even shows up on the outside of the cell. No door handle, no way for the virus to get in. Simple as that.
So, you're probably wondering, just how rare is this thing? The answer? Extremely rare. To get this full-on resistance, you have to inherit a copy of this mutated gene from both your mom and your dad. And that only happens in about 1% of people with Northern European roots. That's why finding a donor for Timothy Ray Brown, it was truly like trying to find a needle in a global haystack.
And it all boils down to this one tiny little change on chromosome 3. The Delta 32 name literally comes from a deletion of just 32 base pairs. That's it. This microscopic edit is all it takes to make the final protein completely malformed, totally useless for HIV. It's a perfect, real-world example of how the smallest possible genetic tweak can have these huge, life-saving effects.
A natural cure like this is just incredible, right? But it also makes you think, where did this genetic superpower even come from in the first place? Because this story,
It doesn't begin in a hospital. It begins way, way back in the past.
You know, a mutation this powerful had to come from somewhere. It didn't just pop up out of the blue to fight a virus from the 1980s. In fact, geneticists have been able to trace its roots back hundreds, maybe even thousands of years.
And check out this map. It shows something really fascinating. See that dark red area? That's where the mutation is most common, and it is smacked right on top of Northern Europe. That single geographic clue is what kicked off some really interesting theories about where it all started.
The leading theory is that this mutation was actually a defense against some other horrible plague from our past. Some scientists think it popped up around 700 years ago, which puts it right in the time frame of the Black Death. Then there's another really cool theory. This is where it gets the nickname the Viking mutation, that it spread across Europe as the Vikings raided and settled new lands. Whatever the true origin, for it to become so common in one area, you know it must have given people a massive survival advantage against some ancient deadly disease.
So Timothy Ray Brown's story proved it. A cure is possible. But let's be real, his cure was a 1 in a million shot, a genetic lottery. That's not a solution for everyone. But this ancient genetic quirk, this old defense against plagues, it gave modern science a huge clue. It pointed us towards a whole new frontier.
So that leads to the big question. If finding a donor with this mutation is a 1 in a million shot, can we just make it ourselves? Could we actually engineer it? Could we take someone's own cells and just give them that same genetic superpower? Well, it turns out the answer is yes, thanks to one of the most powerful tools science has ever come up with.
And that tool is called CRISPR-Cas9. You've probably heard of it. It is an absolutely revolutionary technology that lets scientists edit our DNA with pinpoint accuracy. Think of it like the find and replace function in a word processor, but for our genetic code. It can go in, find the exact gene it's looking for, like CCR5, and make a perfect cut.
So here's the game plan how this could actually work. Step 1. Doctors take out some of a patient's own stem cells. You know, the master cells that build your entire immune system. Step 2. In the lab, they use CRISPR, like a pair of molecular scissors, to snip out that tiny 32 base pair section from the CCR5 gene. Step 3. They take these newly edited, now HIV-resistant cells and put them back into the patient. And finally, step 4. Those new cells get to work building a brand new immune system that the virus literally can't infect.
But, you know, it's not quite as simple as just snipping some DNA and calling it a day. The actual process is incredibly rigorous. Before they even think about trying this, scientists sift through thousands of potential genetic targets, testing and validating every single one to make absolutely sure the edits are safe, that they'll work, and that there won't be any unexpected side effects down the line. We're talking about extreme precision and a whole lot of caution.
Of course, the second you start talking about editing human DNA, you run straight into some huge ethical questions. A few years back, a scientist in China sparked a massive controversy when he actually used CRISPR to edit the CCR5 gene in human embryos. The entire scientific world condemned it. And that really highlights the tension we're in, right? This technology could cure horrible diseases, but it also opens a Pandora's box of possibilities that make a lot of people really uncomfortable.
And that brings us to the final ultimate question. This isn't science fiction anymore. We are right on the verge of being able to engineer our own immunity to diseases. But just because we can do something doesn't mean we should. Having the power is one thing, but having the wisdom to use it correctly is something else entirely. Where we decide to draw that line is going to define the entire future of medicine.